Alright, so we're given this table here with f of x. We have it f of x's value at different points of x. So at x equals 0, f of x is 5. We're also told that we're supposed to approximate the integral from 0 to 16 of f of x using a left endpoint Riemann sum of 4 equal subintervals. So to do that, let's write the integral. We're going to use left endpoint Riemann sum, which is going to be the sum from 1 to 4 of f ci delta x. And this f ci is just saying, alright, when I equals 1, we're going to use the f of whatever x we're supposed to use as the first in the first subinterval, and then I is going to be 2, and we're going to use the x for the second subinterval, and so on. So delta x is going to tell us the difference in x for each subinterval. We know there's 4. The equation for delta x is b minus a over n. B is going to be right here, so 16, and a is going to be here. It's our the values we're integrating from. So it's 0 to 16, and then n is 4. N is our number of subintervals, and our problem gives us 4. So that's going to be equal to 16 over 4, which is equal to 4. So now that we have that, we can find R4. It's going to be equal to 0. So why this is f of 0, our first subinterval is from 0 to 4. So our subintervals are from 0 to 4, 4 to 8, 8 to 12, and 12 to 16. So there are 4 subintervals, they're all equal, and their delta x is all 4, because 4 minus 0 is 4, 8 minus 4 is 4, 12 minus 8 is 4. You get the idea. And since this is a left endpoint Riemann sum, we're going to use the left x for each of those intervals. So we're going to use 0, 4, 8, and 12. So f of 0 plus f of 4 plus f of 8 plus f of 12 times our delta x, which is 4. And that's going to be equal to 5 plus 3 plus 9 plus 11 times 4. That's going to be 28 times 4, which is equal to 112. And that's going to be our answer.